You would be blown away by just how amazing of a user experience you can create with LLMs. And if you give me 20 minutes, you'll be able to confidently develop these agentic user experience, the same exact ones that power Cursor. And to do that, let's uh, get a layout of the landscape, understand the frameworks before we jump into building the example apps. And the best way I think to understand frameworks is to understand it through these quantum leaps in user experience. And so that's defined by three eras, where the first era is sort of post LLM invention, pre Chat GPT. And in this era, the user experiences were really taking advantage of some of the major advances in LLMs, in which you could give it a single prompt and it would give you a pretty good result. And so what you would do is you take the user input here that I've got in purple, and you would wrap that in a system prompt where you'd say something like you're a poem writer, and then the user input might be like what type of poem they want to write, and then you'd give it a bunch of examples. So like if the user told you this, this is what kind of poem to write. If the user gave you this is what kind of poem to write. And so with just a few examples, uh, you could pass that to the LLM and give it back to the user, and it was quite amazing, and it demonstrated the capabilities of the LLM amazingly. And the early SDKs and frameworks that we had were really just wrappers around the LLM. So the LLMs provide APIs, and they would release these SDKs that allowed you to access the AIs, the APIs conveniently. The next quantum leap was post Chat GPT, and this era is the agentic chat UX. And what ChatGPT showed is that if you put something between you and the LLM, if you put this agentic service between you and the LLM that had memory, could remember what you had told it in the past, could access tools, could look up things on websites, could run interesting workflows. Like instead of just immediately responding, it could plan a response. And then, of course, you didn't just send it the input and then wait a minute for the output, but as the LLM produced results, it would stream it back to you. And so this was just really a quantum leap forward in the user experience. And, sort of synchronously with the release and definitely after the release of ChatGPT, we saw these agentic frameworks in 2023. And all these agentic frameworks were making it easy for regular developers, without huge budgets, to create very similar experiences, where you could have memory and workflows and tools. Um, and so the final era in user experience advancement is what I call the UI integrated agentic chat UX. And this is sort of best demonstrated by apps like Cursor and Lovable, although I am seeing some more interesting ones like things that help you write documents and also to help you do analytics. They're showing up everywhere. And in these UI integrated agentic chat UX, you get the same chat that you got with Chat GPT, uh, and you get this same sort of service in between you and the LLM that sort of agent makes it agentic. It gives it memory and tools and workflows. But you also get the ability of the agent to work with your front end. So, uh, like in this particular example, the agent could help navigate to different documents. And then the document that you're working on is sort of this shared state that both you and the agent can impact. And in built and integrated into the chat is this ability of the agent to sort of uh, run actions by you before it takes them, and was called put the human in the loop. Um, and so really sort of post Cursor, post November 2024, the new standard for agentic UX is this UI integrated agentic chat UX. And in November of 2024, when agent mode was released in Cursor, Anthropic also released their desktop client. And this makes a lot of sense because Anthropic and Cursor we're working side by side. Anthropic is the LLM that powers Cursor. And when Anthropic released MCP, they sort of showed underneath the covers of how everything was working. And let me just take a step back here and say, in this era, where we saw protocols emerge, it was not just frameworks, but rules for interaction. MCP being Model Context Protocol, A to A being Agent to Agent Protocol, and AGUI being Agent to User Interaction Protocol. We see this shift to these event-based patterns where agents collaborate, listen, act, and the UX becomes a dynamic shared space. And I won't get too much into the agent user interaction protocol, but it was released in May 2025, and it's now just May 26th, and we've already seen 4 agent frameworks add AGUI protocols to their agent frameworks. And so now I think we've got like a pretty good lay of the land on what state of the art is. And we also sort of understand what frameworks are available to us, what standards we need to use, what protocols we need to use, and what architecture, right? It's this event based integration architecture between the agent and our user interface. And the great news is that we don't have to build all that ourselves; it already exists. Okay, so while a UI integrated agentic chat UX may seem a science fiction and something that only $9 billion companies like Cursor can do, it's surprisingly easy with these frameworks. It's a little bit like piecing together Lego pieces. So what's the app we're going to build? Open the chat. We say Cubs win. It comes back and asks us how much confetti. We say let's go. And it rained 2,500 pieces of confetti. So that had agentic chat. The agent can interact with our UI. We're going to show off a few more features of the app as we go, but I just wanted to give you a brief introduction to it. We're going to build this in 4 steps, starting with a plain non-agentic app. Then we're going to add the chat. Then we're going to add some of these UI integrated features. And so in the non-agent version, you just click a button and it rains confetti. And I want to show this because I want to draw some parallels. Like in React, you have view that reacts to state, right? I mean, that was the whole value proposition of React in the beginning, right? It was this concept of data binding. And we, the developers, exposed to the users the ability to modify state. And the way that we do that is, here in the header where we had that button to make it rain confetti, we create an on-click handler. And in that on-click handler, we set is active to true. And so we basically respond to these browser events to update our state, and then our React app responds to that state. You click the button, it rains confetti. Okay, so that's the non-agentic app. I'm missing a few things there, but I really want to just get to the heart of the user interaction, updating the state. And so once we add chat, you'll be able to slide out from the right. You'll be able to say hello world. An agent will come back and say hello world. So this is really the hello world of agentic chat. And we're going to divide it into 3 steps. The service, that chat component that slid out from the right, and then the AGUI bridge that connects the two. And let's start with the agent chat. This is the whole agent chat file. This is all of it. So, ever since the first era, we've been able to access our LLMs through like these SDKs. And so that's exactly what we're doing here is we're bringing in the OpenAI SDK so that we don't have to like handwrite the API calls. We can just sort of work with this nice model. And then we're bringing in Mastra, which is the agent framework that we chose. And then we're creating our agent. And much like in the first era, you give it the system prompt. What are you? You say hello world. And then we're giving the agent the model that we're using. We're using GPT-40. and then we return the master service, and that's it. That's all. That's all it takes. We can run our server, and our service is now up. The next step is the chat component. And so the way that we get the chat component into our app, here we have our page, and our page is pretty basic. It just has the celebrator component on it. And what we need to do is we need to import CopilotKit style so that our chat will look pretty. And we can then import the Copilot sidebar. And then we mount the Copilot sidebar in our page. And that's it. That's all it took to bring in all the UI for that chat component. And then the last step is the AGUI bridge. And the AGUI bridge is a little bit complicated just because we have to connect it on both the client and the server. So it's going to take 2 steps. And on the client side, in order to understand how CopilotKit integrates with your entire React app, you can understand how React shares state between components. And one of the mechanisms as of 2013 that React gives you is this concept called React context. And a context is any subtree of components can define a context, and then any of the components underneath that subtree can share state. So a child can share it with a peer, and they can update state and react to state. It's React context, and it's a standard in React, and that's exactly what Copilot gives you. Is CopilotKit creates this really souped up context that exposes all the state of your app that you allow it, that you share with it, to be shared with the agent. And then the state coming from the agent can be shared with your components. And so when you wrap your celebrator and sidebar uh, in the Copilot kit, it sort of puts it at the top of that context. And then we just wire up that context to the API endpoint and let it know which agent we want to use at that API endpoint. And that's it. We've now bridged the client side of the AGUI protocol. And so now we need to bridge on the server side. And so on the server side, we're going to use a microservice architecture. And this is mostly because the CopilotKit service is written in TypeScript, and most agent services are written in Python. And so as of like 2015, it's really not much of a burden for IT teams to deploy multiple services that run as their own service and basically communicate over the network. And so what will happen is the React will call out to this service over the network, and then within your backend, the Copilot service, the CopilotKit service will call the agent service over the network, and then the agent service will call back to this and then go back to the React client. And if we're lucky, we're using an agent service that came with a nice client that wraps that API in a way that we can use easily in CopilotKit. And if that agent service, officially supports the AGUI protocol, then hopefully it has those capabilities. And so here you can see we're bringing in that Mastra client, that object that we were just talking about. And then here you can see that we're getting the AGUI version of it because Mastra supports the AGUI protocol. And then we're taking the agent and we're feeding it to the Copilot runtime, and then we're handling requests using this request handler. And that's the majority of the runtime backend. I think you probably saw 90% of the code there between these snippets. We can start this up, and now we've completed the server side of the connection, which brings the AGUI bridge to completion, which brings the agentic chat to completion. And so now we get started with some of these post cursor features where the UI is integrated into the agentic chat. And to do that, what we're going to do is we're going to expose to the agent the ability to rain confetti. We say hello. We say things are great, exclamation point, and then the agent decides to rain confetti. All right, so let's draw some parallels to how we enable React to allow users to start confetti with how it allows agents. So again, in React, we have views that react to state. We expose to users the ability to modify state. In CopilotKit, we expose to agents the ability to modify state. In React, we write handlers for events that the browser creates when the user decides to click a button. With Copilot, we write handlers for events that the service sends when an agent decides to use an action. And I'm going to pause just for a moment to let that sink in. We write handlers for events that the service sends when an agent decides to use an action. All right, what does that look like? Well, we create these use Copilot actions, and these use Copilot actions are built on top of a React technology called hooks. And when we define the Copilot action, we give it a name, start celebration. We give it a description. If things are good, celebrate. And we give it a handler. Set is active true. And this handler should look a lot like the handler that we had on that button. So if you remember earlier in the React app, when the user clicked the button on click, we set is active true. So a very similar pattern, but instead of attaching handlers to buttons, we're attaching handlers to Copilot actions. And I want to point out here that all of this is happening inside the React app where we created this use Copilot action. We haven't done anything to the CopilotKit service. We haven't done anything to the agent service. But through the AGUI protocol, the agent service discovers this front end action, and it decided to call it. Much like a user discovers the button and decides to click it, the agent discovered the action and decided to run it. That's a little mind blowing to me. So agents calling UI sounds a little scary. Let's learn how to put the human in the loop. But before we learn how to put the human in the loop, let's increase the stakes a little bit. Let's give the AI the ability to determine how much confetti rains down. So here I tell it life is great. It gives us a little bit of confetti. And I'm like, no. Let's celebrate orders of magnitude greater. And now it's raining lots of confetti. Now, it was pretty reasonable there in how much confetti is suggested. But it could suggest enough confetti that it might be a problem. But before we get into the human in the loop, let's just talk about how we raise the stakes. So the way that we raise the stake is on that same use Copilot action. We are now using something that we weren't using earlier, which is the parameters the feature. And if we pass parameters to use Copilot action, then when we get called, they'll show up in args. So the parameters that we're asking is for the number of pieces. We let it know that it's a number. We describe it. And then so when Copilot calls our action, it will pass in the number of pieces into args, which we can then use to set the number of pieces. And so when we activate the confetti, it will use those number of pieces. And we basically call set config here, which is part of the confetti status state. And then in our React confetti component, we are using those number of pieces. So now the stakes are increased. Let's bring the human in the loop. And so what this looks like is in the chat, we say Cubs win, exclamation point. It says the Cubs won. How intense? Should we celebrate? It gave us a number of options. We selected 2,500 pieces. It rains 2,500 pieces of confetti. And I want to point out here that here I've got two different chat sessions. One in which I just said Cubs win, exclamation point. And it gave me between 500 and 2,500 pieces as options. And then here, where I said they won the World Series, and this calls for a huge celebration, I get between 1,000 and 10,000 pieces of confetti. And you'll notice that the options are different and the heading's different, but there's a lot that's the same, right? It's the same gray background, it's the same button set, it's the same radio buttons, and this is where we can get some insight into what um, a you know agent generated UI is. Agent generated UI is UI where it may be a component that we created, but the parameters of that component have been provided by the AI. In this case, the options in the heading. And so the way that we do that is instead of when we bring the human in the loop, we don't use, it's a nice experience to have the AI generate some options for us. So here we've told it to give us piece counts plural, and then we put these little brackets on the number indicating that it's an array, and we've also described it as an array, and then we've also said give us the heading, and we've described what that heading is. And so now when the agent calls us, it's going to give us a number of piece count options and a heading, and that's what's going to drive that component. And one of the things that was a little bit more subtle is if we're not taking an immediate action on state, but we instead want to pause the agent execution and get some user input in the chat session, then we render and wait for a response. And when we render and wait for a response, what we're ultimately going to do is be rendering that component. Here we pass in the options and the heading to that component. And if the user clicks the select, the let's go button, it'll call this. And so what happens when they click it is we set the config to the option that they chose. We activate the confetti, and then we respond to the AI with what they chose. So starting celebration with count pieces. So this respond callback is how the agent can resume execution. And so let's look a little bit more carefully here. After we select how many pieces, it's waiting. It's waiting. Once we select, then it picks up the conversation. It knew what we picked. It's in the loop. All right, and that's how to build an example app. And if you've enjoyed this, please connect with me. You can find me on Discord on the Mastra AI Discord server and the CopilotKit server. Um, I look forward to hearing from you, hear what you're building, want to see how you're coming along with these frameworks. Peace.